Vermont. We know it for maple syrup, vibrant fall foliage, and jagged mountain peaks. It's a place that feels deeply rooted in tradition, sometimes even untouched by time. But if you look closer, beneath the quiet exterior, this state has always harbored a restless, inventive spirit. A spirit born from necessity. For over 2 centuries, Green Mountaineers had been quiet pioneers. They didn't just adapt to the rugged landscape, they reinvented the world from it. Tonight, we're going to tell their stories. The stories of the sparks that started right here in the Green Mountains. Our journey begins at the very dawn of the United States patent system. The first ever patent, issued by the new government, didn't go to a famous founding father. It went to a quiet Quaker named Samuel Hopkins. Hopkins' invention was essential for America's first true cash crop. But it wasn't tobacco or cotton. It was potash, a chemical made from wood ash. Potash was critical for making soap, glass, and fertilizer. In 1790, America was covered in forests being cleared for farming, creating an endless supply of ash. At the time, the potash industry was in a bit of a crisis, because the traditional way of making potash, simply boiling wood ashes in large kettles, was inefficient. Hopkins' patent, formerly titled The Making of Pot Ash and Pearl Ash by a New Apparatus and Process, introduced 2 major improvements. First, he had figured out that if you burned the raw wood ashes a second time in a specialized furnace before dissolving them in water, you got a much higher yield and a purer product. Secondly, he mixed the insoluble remains of one batch back into the next, ensuring almost no waste. Thanks to this process, the US remained the world's leading producer of potash until the 1860s, when people figured out how to mine it from the ground rather than burning trees. On July 31, 1790, President George Washington, Secretary of State Thomas Jefferson, and Attorney General Edmund Randolph all signed their names to Hopkins' patent. He had developed a new process and apparatus that made potash production cleaner and more efficient. We move from chemical processes to the birth of electrical engineering. We are in Brandon, Vermont, in the 1830s, at the forge of Thomas Davenport, a humble blacksmith with a revolutionary idea. Steam power was king, but it was dangerous and dirty. Davenport was fascinated by the newly discovered phenomenon of electromagnetism. He saw it as a potential alternative to steam, but nobody knew how to create a practical, continuous motion machine. In 1834, Davenport built the world's first successful electric motor. He didn't have factory-grade insulation. He used mercury as a conductor, and his wife Emily, well, she sacrificed her own silk wedding dress, cutting it into strips to insulate the delicate copper wires. In 1837, Davenport, who was a self-taught blacksmith, received the first patent ever granted for an electric device. His patent was so broad, it essentially granted him the rights to electromagnetically moving anything. Though he died poor, his spark of genius powers our world today, from our home appliances to the emerging electric vehicle revolution. While Davenport was pioneering electricity, another Vermont inventor was solving a more grounded, yet critical problem: commerce. Our scene shifts to St. Johnsbury, home of Thaddeus Fairbanks and his brother Erastus. In 1830, he invented the platform scale. Rather than hanging a heavy load, you just drove it onto a platform. The secret was a sophisticated, hidden system of levers and a single beam at the side, where one person could accurately measure the weight. The invention was a global sensation. Within decades, a Fairbanks became synonymous with accuracy worldwide. It transformed agriculture, industrial manufacturing, and global trade. The legacy of St. Johnsbury's foundry continues to this day, a testament to precision and reliability. Our next story is about a farm boy who hated farming. Elisha Otis was born near Halifax, Vermont, He had a brilliant mechanical mind that was constantly seeking problems to solve. He drifted between jobs, eventually starting a small wagon shop in Brattleboro. Hoists and primitive elevators already existed, but they were terrifyingly dangerous. The platforms were held by simple manila ropes. If the rope snapped, the platform, its cargo, and anyone riding it would plummet to the ground. In 1852, Otis invented a safety brake. He realized he could use the tension of a large, tough wagon spring that, if the rope snapped, would immediately clamp onto a ratchet system on the side of the shaft, locking the platform in place. The event at the 1854 Crystal Palace Exposition in New York is the stuff of marketing legend. Elisha Otis didn't just explain his invention, he staged a death-defying demonstration that turned a boring, mechanical part into a global sensation. Otis had a multi-story open elevator shaft constructed in the center of the exhibition hall. Here is how the show went down. Otis himself stood on the elevator platform, piled high with heavy boxes and barrels, to prove it was carrying a massive load. He signaled his assistant to begin hoisting him high above the gasping crowd. Once he reached the top, roughly 40 feet in the air, Otis gave a prearranged signal. His assistant took a sharp axe and deliberately severed the single hoisting rope holding the platform. In an era where a broken rope meant certain death, the crowd screamed, expecting the platform to shatter on the floor. Instead, the platform dropped only a few inches before the heavy spring-loaded brake snapped into the notched guardrails. As the platform hung securely in midair, Otis tipped his top hat to the stunned audience and calmly announced, "All safe, gentlemen, all safe." Before this moment, the public was terrified of elevators. They were seen as vertical coffins, only fit for moving freight, never people. By putting his own life on the line, Otis proved that his automatic safety brake worked even if the operator failed or the equipment snapped. This single act of showmanship broke a psychological barrier of fear of heights, directly leading to the birth of the modern skyscraper. Without that spectacular afternoon in New York, the skylines of cities like New York and Chicago would look very different today. With this contribution made by a farm boy who hated farming, Otis had shared the Vermont spirit of reaching for the sky. Before 1844, surgery was a nightmare of pain. Patients were often restrained by force, and the trauma of the surgeon's knife was almost as dangerous as the ailment itself. Horace Wells, a dentist from Hartford, Vermont, changed human history during a chance encounter with a traveling show. He noticed a man, under the influence of laughing gas, whack his shins on a bench and feel absolutely no pain. Wells realized the potential. He would test it on himself first, by having a colleague pull one of his own wisdom teeth while he was under the gas. It worked. Though he struggled for years to gain recognition, Wells had discovered the key to modern anesthesia, turning surgery from a torturous ordeal into a painless procedure. In the mid-1800s, Vermont was a hub for woodworking and machinery. But cutting complex curved shapes in heavy timber was backbreaking, slow, and often imprecise work. The primary methods up until this point were the frame saw or bow saw. This was the most common tool for futtock sawing, cutting the curved ribs of ships and furniture components. It consisted of a thin, narrow blade held under high tension within a wooden frame. The narrow blade allowed the sawer to pivot and follow a scribed line, but it required two people, one above and one below the timber, to navigate the thickness of heavy beams. For smaller or tighter curves, a compass saw, a thick-backed hand saw with a tapering blade, was used. It lacked the tension of a frame saw, making it much slower and harder to keep perfectly vertical through thick wood. In 1849, Lemuel Hedge of Windsor, Vermont, perfected the bandsaw. By creating a continuous loop of serrated steel, he allowed woodworkers to cut intricate shapes with a speed and accuracy that was previously impossible. Hedge's design was so fundamentally sound that the bandsaws found in modern workshops today still use the exact same principles he developed in Windsor. He gave the industrial world the gift of precision curves. Sometimes, the greatest inventions are the ones we touch every day without thinking. Take the simple task of drying laundry on a breezy Vermont afternoon. Before 1853, people used simple wooden pegs that often slipped or split. David Smith of Springfield, Vermont, had a better idea. He added a small metal spring to two wooden levers. It was a masterpiece of Yankee ingenuity. Smith's spring-loaded clothespin was so perfect it has remained virtually unchanged for over 150 years. He also invented the hook-and-eye closure for clothing, proving that in Vermont, even the smallest problems deserve a brilliant solution. The green technology movement is also flourishing in Vermont. At the forefront is Bay Ta Technologies in South Burlington. They are pioneering electric aviation with the Alia, an all-electric aircraft designed for cargo and passenger travel. It's quiet, emissions-free, and can take off and land vertically like a helicopter. This isn't science fiction. Beta is already flying their prototypes and building a nationwide charging network. As we look back over these 2 centuries of invention, a clear thread emerges. These Vermont pioneers were never trying to create a massive industrial empire. They were solving local human problems. A blacksmith who wanted a cleaner power source. A farmer who needed an accurate wake. A person who needed hang laundry. They were driven by the conviction that things could be done better. That restless, resourceful, make-do spirit is the invisible current running through these mountains. The sparks that started here are now illuminating the future, proving that in this small, quiet state, the next great idea is always just one solution away.